So one way we have seen like creating the threads by extending a class called as a thread class, right? So today we'll see one more way of creating a thread class, right? In the last session I have created a thread class by extending a predefined class, and that predefined class from a java data lang package. So java dot lang dot thread. So this is the class which I have used, and I have created my class. I have created my class by extending this class. Right? So I have created my class by extending this class. So here I have my class, and my class name I think I have taken like a my thread. So what is this here? So in this class, as we discussed, so whenever we create a thread class, so that means what? Some piece of the code, some piece of the class, we want to execute as a separate process, and executing the part of a program is called as a what? A thread. So for this we need to create a object for a class called as thread class, and so we need to call a start method, right? So where is the start method here? Start method. So if you see the program which we have developed that day, right? Right. So this is my program here. I have my thread extends thread. Right. So this is a program I have. So we have written this program by extending a class called as thread class. This is what I did. Right. So I'm writing the same program one more time. Right. So that we'll see one more time. So what happens here and how the program execution will be. So I'm copying the methods. So it is going to print right. So this is what I did here the other day. Now I have created a thread by extending a class. Now the class architecture is like this. Hierarchy of this classes. So java.lang.thread, and the class which I am creating, which is a child class for that, is extend this class, right? So where I have overridden, as I told you, whatever the piece of code which you want to execute separately, always that piece of code should be written as part of a method called as what? Run method. Right? So this is what I did here. And now once you have separated your piece of code, so if you want to execute that piece of code separately, you need to call a method called as what? Start method. Right? So let's see here how this program is going to behave for this. So ECD yep. Java C my thread1.java, it's fine now, it's compiled without any problem, and my thread. So I can see it is executed fine, and you can see, so these threads will be executing concurrently, but there is a problem with the arithmetic exception in my thread1. Where is the arithmetic exception in my thread1? No, right? It's fine. It's fine. No problem with this class, but the object is created for the my thread class. That is a problem. The previous program is executed in this case. No, compiled and executing here. Now you can see here two parts of your program are executing concurrently. So main is started, but run is in between came, and main run like this. You have these methods are executing concurrently, and this program will be executing differently. If you execute this program multiple times, you will definitely see different outputs, right? So one more time, if you run, is it the same output I got here? It's almost same, no, right? Main is ending here after 95. No, it is a different, right? You can see here. Now each time we are getting a different output. It's not that you should always get a different output each time. That depends on your, that's internally depends on your virtual machine and all thread scheduler. So this is how I have created my class. Now if you clearly see the art picture of this classes, right? So this is my class here, and there is one method is there in this super class thread class. That method is run method, right? So run method is here. So I am rewriting this method in my class. So what is the meaning of rewriting this method in my class? So that is said as what? Overriding. So run method of a thread class I have overridden in my class, and there is one method inside this class that is about start. So as we have discussed, a thread object becomes a thread of execution when you call the start method. So if you want to call the start method, you should always require an object of a class called as what? Thread class. A thread becomes a thread of execution. How a thread becomes a thread of execution? A thread becomes a thread of execution by calling the start method. By calling the start method only, a thread becomes a thread of execution. That means separate memory will be allocated, and it will be registered with thread scheduler, and that method, the code of run method will be loaded into the separate process. All these things happens only when you call the start method on a thread object, right? So there is no other way a thread object becomes a thread of execution. There is only one way where a thread object becomes a thread of execution. What is that? By calling the start method of what? Thread class. By calling the start method of thread class. Yes. Right. So by calling the start method of thread class, then only the separate thread will be created for you, and the run method will be loaded into the memory. Right. So what is this I am doing here? So if you see this, I am creating the object for my class. I am creating the object for what class? Child class. I am creating the object for my child class here. So that what happens here? I have created the object for this class, and this class has a run method, and through this object, because it is a child class for thread class, through this object I can call what? Start method. I can call start method. Right? So what happens here? When you call a start method, the Java runtime is going to create a separate memory, like a separate process, and into that process it is going to load the run method of your class. Run method of your class. Yes, start method is there inside a thread class. You can check the API, right? So what it is going to do here? It is going to, when you call the start method, remember this is a key point. If you want to create a thread of execution, if you want to have a thread of execution, it's only possible by calling the start method from thread class. There is no other way of making a thread as thread of execution. Once you call the start method, it is going to identify the run method, and if the run method is there, it is going to load that run method, and the stack of this thread goes like this. Stack of this thread grows like this. It may go keep on extend like this. Now the start method, because I have created the object for my thread class here, so through this object I am calling a start method. So what happens here? The start method will call the run method of your class. Let's suppose if I don't have a run method in my class, so what happens here? If you don't have a run method in your class, the run method from the thread class will be called. This is inheritance, simple inheritance. So object here, so it is simple inheritance inside this. So object start method first searches for the run method. What is the object I am using to call that start method? This class object I am using to call the start method, my thread 1. So when I call the start method, it searches for the run method in its own class. If it is there, yes, this method will be called. If this method is not there, then this object run method will be searched from its superclass in the thread class. Yes, it is there. The threads class run method will be executed, right? So if you directly call the run method, what happens here? If I directly call the run method, what happens here? Yes, absolutely you can do this, because object of your class, through this object you can call the run method. It is also valid, you can do this. But it will not create a thread of execution. Instead, what it is going to happen here, the run method will be executed on top of what? The main method. So only one thread will be created, that is main thread. That is main thread which calls the main method. On top of main method, run method will be executed. So single thread only. So if you want to make a thread, separate thread, if you want to create a separate thread, you should always call what method? Start method from thread class. But here, as I told you, there is some design wise drawback is there in this approach. What is the drawback you have in this approach? Right? So what is the meaning of, what is the drawback here? There is a simple drawback is here in this creating a class like this. Absolutely it is working fine, so you can see the output here, so that your program is executing, the piece of your code is executing concurrently, right? So without depending on each other. So as we have discussed, as we have seen previously, if one piece is having some exception, if this piece is having some exception, this piece of code is having some exception, so this code is not stopping, it is still executing continuously, right? That is what we observed there. But there is some drawback is there creating the classes like this. So what is the drawback inside this kind of architecture of classes? Yes, the big drawback here, because we are using inheritance inside this. What I am doing here, I am using inheritance. What does it mean here? So my class extends a thread. So what does it mean here? So this is a specialized form. As we discussed inheritance, we take a superclass which contains all common methods, and from that specialized generalized class we will be getting what? We will be creating what? A specialized form of that generalized class, animal, cat and dog. But that means what? My class is a specialized form of what? Thread class. Is it really a specialized form of thread? No, I don't want my class to be a specialized form of thread. What I want, whatever the code I have in my class, there are two pieces. One is run method and other is what? Main method. I want to execute these two pieces separately. That is what my need. There are two methods in this here, right? So I want to execute them individually. I don't want to execute these two pieces of code as a single unit. I want to execute them separately, so that it's fine. So this is my need. For that, what I am doing here, I am making my class as a what? A specialized class of what? Thread class. So what is the problem here you have? What is the problem here you have here? So let's suppose if you take I have a cat class. Let's suppose example I am taking. Just take it as example, right? So I have a cat class. So I want to do the same thing here. Cat class, and there are two methods in this cat class. I want to execute them separately. But if I want to do it, so what I need to do here? I need to create a cat class by extending what? Thread class. If a cat class extends a thread class, is it meaningful? No, cat should extend a animal. But the part of this, there is some multiple parts are there in this class, and these pieces I want to execute what? Separately. So by making this as extending thread class, what happens here? By writing this class as extending this class, what is it is losing here? Is it really a thread? Cat is a thread object? No, cat is animal. That means what? You cannot extend one more class. In Java, what we have? A class can extend only one class at a time. It cannot extend more than one class. So what happens here? This class becomes a specialized form of thread. Is it really a specialized form of thread? No. It is actually a specialized form of some other class. But if I want to execute multiple parts of this class, what should I do here? Right? So once this class is a specialized form of thread, you cannot extend this class to one more. You cannot extend this class from one other class. You cannot do it, because in Java you can extend only one class. So this is the wrong approach. That means what? So whenever you extend a class, this class cannot extend more other class. That means what? Your class becomes a specialized form of thread. If this class becomes a specialized form of thread, this class cannot extend the other classes. No, I don't want a specialized form of thread. I want a specialized form of what? Animal. That is the first thing here. I want this class cat as a specialized form of animal. The second thing what I want here, The pieces, whatever the pieces I have in this, the parts of this cat class should be executed separately. I want both. What I want to do here, I want this cat to be a specialized form of animal. The second thing is, if I want to execute multiple parts of this class separately, I want to do this also. So my class should have different pieces to be executed individually, independently, as well as my class should extend from a specialized class. Two things I want here. But it is not possible if you go for this mechanism. Are you following me what I am trying to explain here? So inheritance is having advantages, at the same time inheritance is having disadvantages also. So in this situation, what is my requirement? I don't want my class to be a what thread, but the pieces of my class has to be executed separately. Because if I make a class from thread class, my class cannot be a specialized form of what? Some other classes. Definitely no. And that is not correct. Right? So in our case, my thread class, my thread one program is not generally need to be extended from some other classes. When you design your architecture of classes, so we have seen lots of classes examples in the inheritance. Then what happens to all those classes if they extend from thread class? No, right? So for this we have a different approach. Instead of one more approach is given for us. Instead of extending from a thread class, very important mechanism. This is what we do. We go with a class called as what? We go with a interface called as runnable. So instead of extending a thread class, there is one more interface is given which works for this multi-threading, and we are going to create a child class for an interface. So what happens here? Now if I can do this, so what happens here? So my thread 1, let's suppose. So what happens here? My thread 1. So what happens here? Now instead of extending a thread class, I'm going to implement an interface. So as we discussed, a class can extend as well as implement. Right? So a class can extend a class as well as it can implement. So what happens here? Now this class can extend its own specialized class as well. It can have what? Yeah, the pieces of this class can, multiple parts of this class can execute what? Concurrently. You will get both by implementing this interface. Right? So this is a simple mechanism. I'm not doing anything here. So instead of going with a thread class, there are two approaches for creating a multi-threaded program. What is the first approach? You can extend a class called as thread class, and the second way is by implementing an interface called as runnable interface. So these are the two approaches you have. Right? So this is what I'm going to do now. So the same program, so whatever we did previously, the same thing I'm going to do, but in a different way. I'm not going to write a new program, I'm not going to write anything here. So what I'm going to do here, the same program, whatever I did here, whatever I have written, I'm going to write this program in a different way. Right? So let's try to do this then. Right? So how I'm going to do this and all, just 1 second. right? So I'm going to do this, I'm going to use the second approach here. Now, so what I'm going to do here, instead of extending this class, I'm going to implement an interface called as, right? So this is the mechanism which everybody does, because now it has this class can extend any other classes, its own specialized class, and right. So my thread 2, the same method here. So as we know that whenever a class implements an interface, it should override the methods from that interface. Now how many methods are there in this interface? There is only one method we have in this interface, again the same method, run method. So again this interface is from lang package. Just if you want to see java dot lang dot thread. Oh, it's not thread, right? It is runnable. See, public interface, runnable interface, and with one method, and that is void run method, public void run method. So as we have seen that if a class implements an interface, so you should do what? That class should override all the methods from that interface. So it has only one method, I am overriding it. Very simple. Fundamental rule. I did not do anything here. Just I have implemented the interface by overriding the methods from it. Only one method I have overridden it. Fine. So my class, I am creating the object for my class, M2 and M2. So what to do here? So my thread 2 dot, what should I do here? What should I do? Start. Can I call start here? Is it going to work for me? My thread 2 dot start. Can I call this? Is it going to work for me? Let us try to do this. No, it's not possible. Sorry. So actually the problem is this program is it's actually implementing that interface, but I think there is one more interface in my local runnable. That is a problem. While discussing interfaces, I think we have created. I have created. Now I deleted it. It's fine now. Now it takes. No, it's not possible. Why it is not possible? See the architecture of classes. So what is the architecture of classes we have now? Runnable, my thread 2, right? So what is my thread 2 is doing here? My thread 2 is implementing what? Runnable interface. See the inheritance, simple inheritance is there inside this, right? So I am not explaining any new thing here. It is implements actually, right? So what I am doing here in my program, so because my class is implementing a interface, and I should override all the methods, and it has only one method, that is run method. Absolutely fine. I have overridden it. This is a simple thing I did, right? Now what I am trying to do here, I am trying to call a start method through my MT2 object, through my class object which I have created right now. Through this I am trying to call a start method. Where is it? Is it there, the start method in this hierarchy? Is any start method you see in this hierarchy? No. Then how it will be called? Your compiler is saying, boss. Your compiler is saying what? Boss, I don't find any start method to call. I don't find any start method to call. Absolutely it is saying the same thing. Because there is no start method in this hierarchy of classes. Then what should I do then? I said if we are able to call a start method, then only you can create what? Thread of execution can be created by calling the start method. Now where is the start method? Start method is there inside this thread class. Now how to call this method, right? So that is where we have here. So this is the class, remember this. So what is this class? This is the class which contains what? The target. Target means what? The code which has to be executed. The code which has to be executed as a separate process. This method is there inside what? A class called as myThread2. It is having the target, and this target to be executed as a separate process, right? And if you want to execute the target to be executed as a separate process, you should call always start method. But the start method is not there inside this class. Where is the start method? The start method is there inside a class called as thread class. So I'm creating an object for thread class now. So I can call the start method by creating a thread object, right? New thread. So this is a thread object. Can I call start method on this thread object? Is it possible for me to call the start method on this thread object? Absolutely I can do. Where is the start method? Start method is from what? Thread class, and you can call this. But this thread should have what target? Where is the target for this thread? I want this method to be target for this thread. So what I need to do here, just we can pass the target object inside this thread object. So what is this here? I am creating a thread, and this thread's target is what? Empty2 is the target for this thread, and I am starting it. Yes, there is a constructor in the thread class. You can go with the thread class. So there is a constructor which takes what? Thread object. Yes, absolutely there is a constructor in the thread class which takes a runnable object, not thread object, runnable object. Just go through the API. So what I am doing here, so this is the class where I have a target. This is the class where I have a target, and I am passing this target to what? A thread object, and I am starting it. So let us run this program now. It's compiled fine, and now let me run this. Program is same, so but the different way. Now you can see the output here. Now it's fine running. It's fine running now, right? So let me separate these two into two different classes so that we try to understand this. So what is this here? I am going to write this class as a target. My class is what? Target. Oh, there is already a class, predefined class called as target, it seems. Okay, then we make it as thread target. .java, right? So this is my target thread class, right? Fine. And what is my, this class is main thread. Now this class need not to be implement any runnable. Just I am separating the pieces here. Right, see this? So what I need to do here, there are two classes here now. Thread target here. In this class I have a target method. In this class I have a target method, and this is implementing what? Runnable interface. This is implementing the runnable interface. Now there is one more thread here. So this method will be called by main thread. Now from the main thread I am going to create an object for what? Thread target. And what is this? Thread target. Now I am going to pass this thread target object to what? TT to a thread, and thread data start. Getting me? So what is this here? A thread target class, target method for all threads here. So it's not all threads, whatever the threads you want to create, whatever. So this is the job. Generally we say it as threads job or threads target, and this is the thread. Now when I call start method on this thread T1, what it is going to do here? T1.start is going to identify its target. Where is its target is located? Its target is located in an object called as what? TT. This is the object where its target is located. Right? So what happens here when you start running this program? main thread will call main method. Main method will go into what? Main thread. And this is the new thread I am creating, user defined thread. So what is this? It's this thread target. Its thread target is what? TT. And this target object has a method. Right? So this target object has a method. What is that method it is having? Run method. And when I call thread dot start, what happens here? It is going to create a new memory, and into that memory that run method will be loaded. So main thread will run main method, and the target thread will be this T1 will run what? Its target method. Are you able to understand now? Right? So what is this class? A simple class. Nothing is there which is implementing a runnable, and it has a target method. And this target object, the object which has a target, I am passing this object to a thread class. Why I am passing this object to a thread class? Because start method is passable. If you want to call the start method, you require a thread object, because this method is from only thread class. This method is from only thread class, right? So this is what we have here. Now let me run my program. What is that program here? Java C main thread dot Java main thread. See here, both are executing. Your main thread is executing as well as what? The target thread is also executing. Right? So this is what. So like this, multiple threads can have what? The same target. What is the meaning of multiple threads? Thread 2 is equal to new thread. And what is the meaning of this? What I am trying to do here? I am trying to create a thread. I have created one thread, and this thread has what? A target called as TT. Target method. Target object as TT. Again I am trying to create one more thread, and this thread is also given the same target. This is called as multi-threading. Or multiple threads can have multiple different targets. So multiple different targets means what? Create one more target class, and pass the object to what? Some other thread. Right? But here both threads are having the same target. Both threads are having what? The same target here. You following me? So what happens here? How many threads are there totally in this entire program? If I run my main class, so how many threads will be there in this main class? 3 threads. What are the 3 threads you will have? By default, one thread is main thread, the second thread is this one, 2 user defined threads, and one main thread. Right? So that means, and both these threads are having a same target called as what? Run method. So we will be seeing the message from run method. Run method will be executed twice on 2 different threads. Run method will be executed on twice on 2 different threads here. Right? So that is what we have here. Now let us run my program so that you can see the run method will be executed twice, because both threads are having the same target. Right? Fine. See that it's taken long time here, but if you observe, run 100 and see here, run 100 twice. So why we are saying run twice here? Because both threads are having the same target. 2 different threads are having the same target. Right? So this is what multi-threading. So this is how we create the threads. So what is the advantage you have here? Now this thread class can extend some other class also. There is advantage you have here. So this is having a target method. Right? Now if you put all these things into architecture, right, very interesting architecture is there inside this. Right? Let me go with this Java profiler. Just see the class architecture. This is very important. Very simple architecture of classes are there here to understand. Right? Right. So here first we try to see Java P, Java dot lang dot what is it class? Thread. Very interesting point about this class is, see this, This class is also a child class for what? Runnable interface, not different thing. This is also implementing what? Runnable interface only, like my class. Like my class, this class is also implementing runnable interface, right? So that now if you put the classes in architecture hierarchy, then you can understand what is happening there internally, right? So let us try to define the architecture, complete architecture here of these classes here. So you have seen that what is it? The top interface, the super interface here of this is what? Runnable. Let's try to focus here, guys. Here. So the super interface runnable is the super interface for all thread classes. I can see. Now this is a predefined interface, and that predefined thread class, what is that predefined thread class, is a subclass for this interface only, right? The thread class is also a subclass for this interface. It is not a different story here you have. So what? It's not a different thing, same thing. What does that mean here? If a class is implementing an interface, so what this class has to do here? Absolutely, this class has to override the run method. So there you will find one method, one compulsory method you will find in this class, that is what? A run method, because it is also a child class for what? Runnable interface. Definitely it should override this method. There is no exception for this, right? So then the first program which I have created, is from this class. What is it? My thread. The first program of our session is from this class. So what is this class hierarchy here? What I did here? So this is thread class, and this is your class, and which is extended from what? This class. This hierarchy here, right? And one important method is required for this, which creates you the thread of execution. That method is inside this class. The start method, which is going to create you a separate process and all, this method is inside this class. This is the hierarchy of classes which we have previously. Yes or no? First program is like this. So what happens here? Now when I create a object for my class empty, and when I call empty.start, so what I did in the first program actually, now in the first program I have actually overridden the run method. What I did here? I have overridden again the run method here. So what it is going to do here? After overriding this method, what I did here? I have created the object for what? My thread class. And because it is a child class for thread class, I can call what? The start method. I am able to call the start method because it is a child class for thread class. Then what is the start method is internally doing here? Because it is already implemented by the Java programmers. So the code inside this is, it searches for the run method. And it searches for the run method on this object, because the start method is called on this object. And this start method searches for the run method on this object. It is finds, it executes this run method in a separate process. If it is not finds, then the run method of that class will be executed, right? So that is what we have here. It is already implemented. The code is implemented by the Java programmers, so it searches for the run method, and if it is finds, it's executed. Again, simple inheritance inside this, right? The second, whatever the class I have created, the second mechanism, so where my class sits in this, my target class, what is it? Thread target. It sits here in this architecture, right? My thread target class sits in this location in this architecture. Yes or no? Right? Now what I am doing here? Now this class is implementing runnable interface. There is no exception. For this class also it should do what? It should override what it should do here? It should override the run method. Yes, I did it. Now in this case, is it possible for me to call the start method on this object, TT object? Is it possible for me to call the start method on this TT object? It is not possible, because there is no start method here as well as there is no start method here. Then how can you call this? It should compulsory implement the run method. If it is not implementing the run method, you cannot create the class. First rule. You cannot create the class if a class is implementing a run, if a class is implementing an interface, and you cannot create the class. And if you want to make a separate process to be created, it should always happen by calling the start method of what? Thread class. Getting me? If you want to create a separate process, it is always happens by calling the start method of thread class. So what I need to do here? So I have created a run method in my thread here in this class, but I want to execute as a separate process. This method I want to execute as a separate process. This is happens only by calling what? Calling the start method of thread class. So what I did there, so I have created a thread object. T is equals to what? New thread, because I need to call the start method from the thread class. And if I call t dot start, what happens here? T dot start. Simple inheritance. As I told you, it searches for the run method. Now what is the object which I am trying to call here? T is the object. On this object I am trying to call the start method. Yes, T is a thread class object. In the thread class you have a start method, it calls it. Absolutely fine. Start method is called. But where is the run method? It searches for the run method and its own run method will be executed. But I don't want this class run method to be executed. I want this class run method to be executed. So what should I do here? What should I do here? In this case, if you want the target run method of this class to be executed, you need to pass the object of the target class inside what? This one. So there is a constructor. So what I am passing here? I am passing a target runnable object. I am passing a target runnable object. So there is one constructor in the thread class which takes it target runnable object. So what is the meaning of this? Target thread target. Simple inheritance. Target some tt is equals to what I am doing here? New thread target. New thread target, like this I am creating my object. Then afterwards creating my object, what I am trying to do here? I am trying to pass this object to what? This method tt. So what is the meaning of this now? So whenever you pass a target object to this thread, now it is not going to call the run method from thread class. Instead it is going to call the run method from its target object. If you don't pass it, it calls the run method from its own. If you pass the target object, it calls the run method from what? The target object. Now that is how this target will be called. As I told you, there is two ways, right? So what are the two things we need to do? We need to separate the piece of code. First thing, I have the statements whatever I have given. What is the meaning of this? Create a thread object. Create a thread object. So this is what I did here. And write the piece of code. Write the piece of code which you want to execute as a separate process in the run method. I did it. In both cases I did the same thing. In both cases I did the same thing. Here also I am writing my target code which I want to execute separate process in the run method. Here also I am writing the same. And in both cases I have created a thread object to call that run method. And in both cases it is same, calling the start method. Directly not run method. But in one case I didn't pass any target object. But whenever your class directly extends a runnable interface, so you should pass that class object to a thread. The class object to a thread. Right? So this is how, this is the best approach. What is this? This is the best approach. Because what is the advantage you have here? There are both ways you can do. But what is the advantage you have here? Now this class can extend some other class. But in this approach, this class cannot extend some other class. It is fixed. This class can extend some other class. This is the best approach and better approach. So that you will clearly have what? So your target is inside some class. Target is inside. Target code which you want to execute separately is inside some other class. And the thread which is calling that target is inside, defined inside some other class. Like this. It is more clear and it is easy to maintain your class also. Right? Now are you able to understand this? What I am trying to explain? Did you follow this second approach? Is it clear? No, there is no start method which takes the target. You cannot pass the target inside the target start method. There is no start method which takes what? Object. Just go through the API. These methods are not created by me. Only one method which is start without arguments. You cannot pass arguments. Calling the methods of a class. If you want to call the method of a class, it should be there. In the thread class you have a start method without argument. Just go through the API. So what is this? You are trying to call it start method by passing a object. It should be there in the thread class. What is object? Thread object. Start method. It is not there in the thread class. You cannot do this. These methods are not created by me. First, right? Saying what? You don't have this method in the thread class. Sorry. You cannot call this. Only one method is there, one start method, and which takes no arguments. Right? So this is what you have here. Is it okay? Did you understand what I'm trying to explain? The second mechanism. Yes. Yes? Did you understand or not? Yes. Right? So this is what we are going to simple here. So if you want to have multiple targets, you can write multiple targets. Right? Target 1 or target 2, and this is suppose target 1. Like this you can write. So target 1 pass target 1 to what? Thread 1, target 2 to thread 2. That's your choice. How many threads you want to have and how you want to create. These are all your choice. It's up to you. Right? So like this you can do this. Right? So this is what here multi-threading. Multiple threads here. Actually there are 3 threads. One main thread by default, which always will have a main method. Then from the main thread I'm trying to create what? Other threads. So what happens here? What is the hierarchy here you have of your threads here? So your threads architecture will be like this in that program. So what is the architecture? The main thread, it has its own call stack here, and from this I have created a thread. From this I have created one more thread. 2 child threads are created for this. 2 threads are created from this. So main thread will have its own method inside its stack. This thread will have its own method inside this stack. It will have its own methods. So what is the method inside a main thread stack? What is the method inside this thread stack, and what is the method inside this thread stack? So main method goes into this stack. Main method goes into this stack, and run method goes into this thread stack, and one more run method goes into what? This thread stack. Both threads have the same stack, and the stack can grow like this. It's not only run method. From the run method, if you call some other methods, the stack grows. From the run method, right? So the stack grows like this. You can, from the run method, if you call any other methods, so that method will be placed on top of run method like this. The stack grows, right? So this is what this program is doing for you. This is what this program is going to do for you, right? So this is the program we have here, right? So we'll continue with the discussion here. Now if you see the outputs, how many times I am running here, if you see the outputs here, main thread. So how it is executing here. Now if you see the outputs, definitely you cannot guarantee which one starts first, which one stops end, which one completes first, and which one completes last. Nothing you can guarantee. See, main method is completed somewhere in the middle. Main method is completed somewhere in the middle, and you got what? Still some other threads are getting executed. Some methods are still executing. As I told you, main method completion is not the program completion. Main thread completion is called as what? Program completion. Right? So that you cannot guarantee which starts first, which completes first and all. Main will be starts first, but which thread completes and first and which thread completes last you cannot say, right? So all are started nicely. Then you can see the jumbled output here, right? And the run is completed. I don't know which run this is, first or second, I don't know, right? So if you want to see how many threads are there in your code, so you have a method given, right? So there is a mechanism where you can call a static method. In the thread class, there is a method called as current thread, which gives you the thread object. Threads are objects only, which gives you the thread which is calling this run method, And if you want to know the name of the thread which is calling this method, there is a method given for this get name. What it is going to do for you? It is going to get the name of that thread. So what is the meaning of this? It's simple. Calling the methods of thread class. I'm not doing here thread dot method name, static method, thread dot method name. This gives you the thread object which is calling this method. So, and name of that thread. Each thread will be given a default name. Each thread will be given a default name, and we will see here. Here also I'm doing the same here. Instead of writing my own, I want to see whether there are threads or not. So main method will be called by main thread. So thread dot current thread dot get name gives the main name of the thread which is calling this. Right, see this? You can see this clearly output. The name of the thread is main, which is calling the main method. Thread 1, that means what? Second thread, and thread 0. 3 threads we have. The names of these threads are main is one thread, which is calling the main method, thread 1 and thread 0. These two are calling the same target. By default names are given. Right? 0. The name starts from thread 0 and it starts from what? Thread 1. Right? So these names are given by the virtual machine. I am not giving these names. If you want to change these names, absolutely you are free to change these names. Right? So see here how many threads. Main thread is the name of the main thread, and is the name of the second thread, thread 1, and it is the name of the first thread, user defined first thread, thread 0. And if you want to change it, you can change. See here, thread 0, 0, 1, thread 1. Now if I run this, you can see different output, and very interesting main method is completed last. Here also thread 0, main, like this, the same, thread 1, all are created for you. Thread 0 started, thread 1 started, then main started. So like this, right? So how, and if you observe these outputs, what you can say at a time, if I take at a time, how many threads are executing at a time? How many threads are executing at a time? Right? So if I see clearly output, if I see all outputs here, at a time only one thread is executing, not all three. And all these threads are executing what? Simultaneously. All these threads are executing what? Simultaneously, because I am using the single processor here, and at a time only one. That means what? See here, thread 0. When thread 0 is executing, where are other threads are sitting? When thread 1 is executing, where are the remaining threads are sitting? So it is executing one statement of this one. What about the other threads? Where are they? Are they executing here? No. When the opportunity is given again to thread 1 here, where it is started? Where it is stopped. See the statements of sequence of statements. So first only one statement, then it is removed, then the other thread is started executing, it is removed, then the other thread is started executing, it is removed, then the thread 1 is started, thread 0 is started. When again the thread 1 is started, where it is starting its execution? It is starting where it left the control. It is executed 1 statement, and again it is started executing after the statement, right? Again from here it is given the opportunity here, after 1, 2, again it is given here, again twice here. If you see at a time, only one thread is executing, not all, because it is sequential and because I am using the single CPU. If it is multiple CPUs you are using, you can see multiple threads can execute, right? But here, then how it is happening here? Who is doing this? If you observe this, after executing the statement, it is removed. Who is doing this? Who is removing this? Then who is given the opportunity to execute this one? And it is not again always it is same output you can see. Oh, very different output, completely different output you see here. Who is doing here? So thread is executed one time, main, again this one, nice, now main, this one, and main. Who is doing all these things? Right? So first thing we need to understand here is threads are not different things. threads are again objects. It's the object of a class. It's not a new thing here. It is an object of a class. And that class is what? Thread class. Right? So this object, as we have come across different objects, right? And each object has its own different way of, we have come across, as again it's not a new thing. We have started with normal objects, then immutables, then exceptions we have seen in the middle, right? Exception objects, and then serializable objects we have seen when we have discussed IO package. The same way these are all objects. And coming to the objects creation, to objects deletion, every object in Java has its own life cycle. Every object in Java has life cycle, and this is not a different thing. So this thread object has also its own life cycle. Now this is a very important concept to understand, right? The complete flow, what is happening there, what is, how this output is getting printed like this, who is doing all these things internally. So if you want to understand this, understanding this life cycle is important, right? So this is again a Java object. MSBA. Right, fine. Fine. So what is the life cycle of this object you need to understand here. So this objects, thread objects has, in its life cycle, they have 5 different phases. 5 different states I can say, right? So 5 different states here, and these states are defined like this. Very important diagram to understand. So this is a different object, and these are the 5 different states you have for this object, right? So, and a object in the life cycle, a object moves from one state to other state, and it can switch back to other states also, right? So as we have changed, values changing is called as what? Object state change. This is not a new thing I'm explaining again, object states and all, right? So it has a different life cycle. This object has its own life cycle, different life cycle comparing to the normal Java objects. And this life cycle starts, how this life cycle will be started and how this is enters into this life cycle, we try to see this. Right? So these are the 4 states here, and on top you have some other state like this, like this. It's done here. Now there are names are given for each and every state here. There are some names are given for each and every state. Now we describe what are these states here, right? And see here, this is a very important diagram to understand. And if you have this diagram in your hand, you can simply explain the threads, right? So this is called as new state or newly born. New state, it is called as new. Now this is called as, is a very important state out of this life cycle. This is called as ready state, or we call it as runnable. Ready or runnable. Right, so what is this state is called as? Ready or runnable state. Right, and this state is called as running. And this state is called as dead. Creation to deletion, same object, birth to death, life cycle. In the same way you have this here, the separate state we have, this is called as sleep mode, or we call it as IO blocked, or we call it as wait. Some different names are given. IO blocked, input output blocked here, like this you have here. What does it mean here? What actually the meaning of this one? Right, so what is the meaning of this one now? What is this life cycle? IO blocked here, actually E is missing, D is missing. Fine. So what is the meaning of this life cycle here? So which state? defines which statement in my code, defines which state here, right? So try to understand this. Now here, whenever you create a new thread object, the new thread object, that means what? What is the statement I am using to create a thread object? Thread T is equals to new thread. This is called as a newly created thread object, newly born. But it is not a thread of execution. It is a normal Java object. It is not a thread of execution. Thread of execution means what? Having separate process. Separate from what? Main thread. It is not now. It is not a thread of execution. It is only a thread object, normal Java object. That is what we have seen. Now if I call run method, what happens here? If I call run method directly on this, what happens? It will not execute run method separately. That run method will be executed on top of main method. Here in this case it is not, right? So that is what? It is a normal Java object. It is not thread of execution. What does it mean? It is, this object does not have any separate process to execute. It behaves like a normal Java object, and through this object you can call the methods of this class, right? So the methods of this class can be called. Let's suppose here, now here in my program, this is a thread only. It is not a thread of execution. So this class has some methods and you can call them. Now I am calling one method of this. So as I told you, each and every thread will have a name. Now if you want to change that name, you can use a method called as set name. So what I am doing here, I am calling a method. That's it. Normal method. This is normal, is an object, and through this object of this class I am calling its own method. Yes, there is a method called as set name. In the same way, I am going to call the method of this one set name. It is not a thread of execution, no separate memory, nothing now. This is what? Second, a normal thread object. This is a normal thread object, right? So this behaves a normal object. It behaves a normal Java object. No special behavior is there for this object now, right? Now at this moment, if you try to call, there is one method is there to check whether this is a thread, a normal Java object, or it is a thread of execution, right? So there is a method is there for you, and this method is, what is it? T1 dot is alive. What is this is going to do for you? Is alive method is going to do for you what? It is going to is alive means what? It says what? Whether this is a thread object or not. Whether this is a thread object or not. Right? So now let me comment all these statements here. No, let it be. Now let me run my program. So what happens here now? You can see it's fine. Somewhere you can see false. What is the meaning of false? And you see the names of the threads. Previously they are 0 and 1. Now we can see there first and second. Okay. I am changing my own names from the default names which are given by the Java virtual machine. I have changed them to my own names. And is alive means what? Is alive means whether it is a thread of execution or not. No, it is not a thread of execution. Now up to these three statements, it is a normal Java object. It has no special memory, it has no separate path, it has no separate execution. Now when it becomes a thread of execution, right? So when you call a start method on this newly created thread object, what is this? When you call a start method on the newly created thread object, then what happens here? It becomes a thread. It becomes a thread means what? Now it has a separate memory to execute some part of code separately. Now the run method will be executed separately. Right? So this is called as what? So when you call a start method on thread object, it becomes what? Thread of execution. It becomes a thread of execution. Now this thread object can have its separate memory. This thread object can have what? Separate memory. Into that memory it can execute some piece of the code of your class. right? That means what? Now it becomes a thread of execution after calling what? Run method. Now I'm copying this. Let's see what it is going to do here. Now after writing this, somewhere you can see in the middle, I think a true statement here. Now see this. If I run my program, somewhere you can see true in the middle. Yeah, at the top only you can see here false and true. First is it a thread? Live means what? Live means what? Whether it is a thread or not. No, it is not a thread. It is a normal Java object. Now whether it is a thread or not. Yes, it is a thread. That means what? It has a separate process allocated. When it is happens, when you call the start method on the thread object, then it happens. Right? Now this is what here. Now there are 3 threads. It's fine. So there are 3 threads. Means what? One main thread which is calling this main method, and there is a thread with the name first, and there is a thread with what? Second. It's fine. But at a time, all these 3 threads are executing. What is happening here? Right? Thread start means it is not executing. The thread calling the start method on thread means what? It is not executing. Then what is happening there? What is happening there? All threads goes into a pool. All threads goes into a pool means what? All threads. So immediately it is not going to execute. So all threads will wait here. How many threads are there? They will wait for their opportunity. Getting me? So there are 3 threads. No thread starts directly executing its code. What is the meaning of this? All threads immediately started means what? They are going to into a certain pool here, and they are waiting in this pool. Then what is the meaning of this? Now from this pool of threads, one thread will be picked. One thread will be picked for execution, and if the thread, and it is who is going to do this task for you. There is a program kind of thing, you can simply assume, what? Thread scheduler, which is going to do this. There is a thread scheduler in Java. This is going to pick one thread out of all these. It is going to pick one thread, and after picking this thread, what is the meaning of this? It puts all these threads which are there in the pool, takes one thread out of this pool. You cannot guarantee which thread will be taken out and which thread will be given out. It's all depends on this one. It is going to decide, and it is implementing. Generally these thread schedulers implements a algorithm called as priority algorithms. In Java, generally it uses priority algorithms, but it will not work. It takes one thread out of from this pool, and it gives an opportunity for execution. That means what? So there are 3 threads. One thread will be taken out, and it will be given an opportunity. That means what? Is this thread, whatever the thread which is given an opportunity, is it going to run completely? No. Again it can move back to what? This state, and which is all decided by what? This scheduler. That is the reason why you can see here one thread started is executing, and it after 1 or 2 statements it is moved back to what? Again what? Ready state. Who is doing all these things? This thread scheduler is doing all these things. So that is the reason why you will be seeing different outputs. Each time when I execute different outputs, because you cannot control this. It is completely there inside on thread scheduler dependent. It is completely thread scheduler dependent. Now you can see here. So all 3 threads are given, each one is given one opportunity here, and they are executed some nicely up to some statement, and then now gone. So main thread is given this much of time, and it is executed, and then something different behavior you can see each time. It's completely depends on the thread scheduler. Some kind of implementation is there internally in the Java virtual machine. It is going to do all these tasks for you, and this implementation will be different from virtual machine to virtual machine. You cannot say what is going to happen here, right? So it is completely depends on this thread scheduler. It picks one from this pool and it places here, and it can once you cannot guarantee. That means after 1 statement, 2 statement, 3 statements are, it can complete its task. Then it can move it back to what? This ready state. When it is moved back to ready state, what happens here? Then some other thread can be given an opportunity to execute some statements like this. So these threads are going to move in and out from what? ready to runnable. So they can switch back in these two states. These two states can be switched back here. So move front and like this, by this thread scheduler is going to do all these things for you. Right? So what is the meaning of running? What is the meaning of running state here? Right? So when a thread enters into run method, when a thread starts its execution, its run method, then it is called as currently running thread. And you cannot know how many statements of this run method will be executed each time. You cannot guarantee. It all depends on the thread scheduler. Alright? So they will come back and all. One important point to be remembered is always a thread enters into running state. Always a thread enters into running state from runnable state only. A thread, there is no way of thread enters into this running mode. From nowhere it can enter into this running mode. It can enter from runnable or ready state to a running state, and it is decided by the thread scheduler. Imagine this is a simple kind of program or something inside your virtual machine which is going to do here. Getting me? Now once a thread completes its execution, that is called as what? Dead. That means what? Once a run method is completed its execution, that thread is called as, once run is completed its execution, it's completed. Right? Then it is called as what? Dead thread. Right? So it is completes its execution, then it is called as dead thread. And very important point here, once a thread is dead, you cannot restart it. Restart means what? You cannot call the start method again. That means technically you can call a start method only once on a thread object. For a thread object you can start only once. You cannot start multiple times. If you try to do it, Java throws you an exception. Java throws you an exception, right? So a thread in its lifetime only started once only. Once it is dead, you cannot start it, restart it. No, it's not possible, right? So this is what you have here. Then there is a special state you have where by calling some special methods on a thread object, a running thread can be entered into what? A running thread can enter into this state, and if you want to do this, you need to explicitly call some methods on the thread object so that a thread can enter into what? This state. It is not by default, but the by default means what? So these four states I can say what? By default. Not by default, anyways you need to call these methods here. Start method you need to call, then only its life cycle starts. If you don't call start method, there is no thread, there is no, it's a normal execution. And if you want to, if there are some methods, so here, that means what? So there are some methods are given for us. So if you see the output here, each time when I'm running my program, you cannot predict the output. One thing you can guarantee that each started thread runs to completion. Each started thread runs to completion. In the same order, how it is started, in the same order it is going to complete it. And the program will be executed when all threads are completed. When all threads are completed, your program is going to execute. See, not the main method, and you can see here, main method is completed, still your program is under execution. So these many statements are executed after main is completed. Lots of statements are executed after the main method is completed. So main method completion is not program completion, right? Remember this. Somewhere in the middle it is completed. No, it's not required also, right here. No, this is what you have. All threads completed, your program is completed. That means what? All threads completed, your main thread is completed. So this is all four states I think we have completed. Up to now, we have created a thread object, we call a start method, then it enters into a ready state or runnable state, and from that the one program you can say which decides which thread should be executed. It all depends on the thread scheduler, right? And how many statements it should execute, when it is going to take a thread from a running thread, it is going to place it back to runnable, or which thread is taken from this runnable state placed to a running state, you cannot guarantee. It all depends on the thread scheduler, right? And once it is completed the execution of run method, you can say what? That thread is killed. Once it is completed this run method execution, this is called as thread is killed. It is dead. But there are some methods are given. So what is the use here? If you cannot predict the output, if you cannot predict how your threads are behaving, then you cannot guarantee the program. Right? So there are some methods are given in the thread class. By using these methods, you can somehow force the thread scheduler. You can somehow force the thread scheduler to behave in a different way. So if you want your threads to be behave in a particular order, if you want your threads to be behave in a particular order, there are some methods are given, and you can use these methods and you can call those methods on the threads, so that you can force the thread scheduler to execute your threads in some a particular order that you can do. So as a programmer, you should do manually. You should call these methods manually. And when you call these methods, then a threads can enter into, sometimes they can enter into what, sleep mode or some other state and all. But once they wake up, they always enter into what? Ready state. That means what? Here from running mode, they are entering into what? From running mode, they are entering into sleep mode. Once they wakes up, they again enter into what? Runnable state. Once they wake up, they enter into what? Runnable state. That is what you have here. Right? So this is what? And these four states, nothing. Just when you call a start method on thread object, that's then it enters into ready state. Then from this execution run method automatically identified by the start method, and then completion of run method is called as dead state. And if you want your threads to behave in a particular way, then you can do it by forcing them, by calling some methods. Okay, did you understand this life cycle? No? Yes? My program is simple. My program is written in the same way. It's not different thing. This is what? Newly born state. This is what? Ready state or runnable state. And calling this run method is what? Running state. Completing this run method is dead state. Simple. Only 5 states for these objects. No other special states. Okay? No doubts? You can ask so that we will clarify our doubts. Then we move on to the next. Fine. I'm not getting any replies. It's okay. Still. It's okay, fine then. Shall we move? So shall we see this state? This one. How a thread can enter into this mode. Very simple, not complex. I'm not going to write any special program to do this, right? So there are some special methods are given for this, and by calling those methods, a thread can enter into this mode. Right, so what does it mean here? The first method here, and very simple methods, right? So now see this, what I'm going to do in my program is, right, so I'm going to call one method where a thread, one method is given for us where a thread enters into this mode, and that method is what? There is a method given for us, sleep. It's a static method which takes some time in nanoseconds, milliseconds, right? Which takes some time in milliseconds. So by calling this sleep method, a currently running thread can enter into what? The sleep mode for that particular time period. Yes? Now how to call this sleep method? We'll see here. Is a static method, and static method of a class can be called by using what? Class name. Now I'm going to do here. So what I'm doing here, each iteration of my for loop, I want the thread which is calling this run method to sleep for a particular period of time. Sleep. Right? So I'm going to pass some, this is 100 milliseconds. Right, and this method throws an exception called as interrupted exception, which is checked exception. So when you have a checked exceptions, you need to handle them manually. Try So why I am putting try and catch blocks here? Because this sleep method throws us an exception. Checked exception called as interrupted while it is in sleep mode. If some other thread interrupts it, in that case it is going to show you such kind of exception. Interrupted exception IE. Yes, I'm not going to write any statement here. Now let's see what is my program and how my program is behaving. So this is what here, my target run method. Yes. And inside this I have a for loop which is going to iterate for 50 statements, 50 times. And with each iteration of my for loop, I am making my thread to sleep for 100 milliseconds. 100 milliseconds. That's it. Now let us run my program. So how my program is going to behave, let's see. Fine. See there, you can see some simple pass. With each iteration of threads, there is a simple pass. See? Right? Can you see that? I'm removing this is alive now. Now what is the meaning of this here? Now what is the meaning of this? Both threads are having the same target. That means both threads are going to call the same run method, and with each iteration both threads enters into a sleep mode for 100 milliseconds. Both threads, right? But main thread, no, there is no sleep for main thread here. What is main thread is going to behave? See there, very nicely they are executing each time. So main, if you see the output, now what happened here, main is computed first. Main is computed first. Why main is computed first? Just you can give some guarantees in this output. What is that guarantees? Now you can give some guarantees here. Now what is that guarantee you can give for this program? Always main completes first. Why always main completes first? Now let's see, let us analyze this. Right, so it starts executing from this. Main method will be called from what? This one will be called from main thread. Now it is creating a one thread, and this thread is started, and this thread is started. Both threads are started. Now what happens here when the both threads are started here? Now both starts executing the same run method. Now when they started executing, first they enter into what? Sleep mode. For how many seconds? 100 milliseconds. First thread comes into this, sleeps for 100 milliseconds. Second thread comes into this, sleeps for 100 milliseconds. When both threads are entered into sleep mode, the main thread started executing its for loop and it is completed. That means what? Before they wake up, main is completed its task. See here. Always you are going to see the same output here. Main will always complete first. Before they wake up, both are entered into the sleep mode. Before they wake up, main is completed its execution. Always main, no. Now you can see there is some different output here, but main is always completes first. See here, main is completed first. Right, let me run one more time. Main is always completes first because they wake up. After wake up, after they wake up, then only they can execute it. See there. So what is happening here? All these threads are executing, these two threads are executing nicely. So before this thread is waked up, main has completed 45 statements. Then it is executed one statement, again it is entered into what? Sleep mode. Then main started. Again second is started. Main is completed. So one, it is entered into sleep. Then it is entered like this. Wake up, print it. Wake up, print it. Wake up, print it again like this. So what is this for loop each time it is going to do here? So it is going to sleep, wakes up. It is a very important thing to understand. What it is going to do, let's suppose if I take one thread here, it enters into the for loop, it sleeps for some 100 milliseconds. That means what it is going to do, it enters into the sleep mode. So it enters into this mode. For how much time? It enters into that mode for 100 milliseconds. 100 milliseconds it will be there in that mode, right? So what happens here after it wakes up? After it wakes up, what it is going to do here? After it wakes up, it is going to come into this mode, ready mode, because it is entered from running state to what? Sleep mode. That doesn't mean that once it is wakes up, it directly comes to running mode. No, it always comes to ready mode from this thread scheduler picks here. Now when a thread scheduler picks for it again for execution, from where it starts here, that is a key point inside this. Where it starts execution here, right? So where it starts is execution, where it left the control. So it is entered into sleep mode from here. Once it starts again its execution, it starts from this statement. What happens? Let's say what is the flow here? Now see this. Let's suppose take one thread as example. First thread comes into this block. It sleeps for 100 milliseconds. Before starting execution only it is enters into the sleep mode. 100 milliseconds. When it wakes up, now it prints this. So when it prints this, what you are going to see? 0. Right? Then again, after executing this entire for loop, then it goes for loop on top. Again it starts executing. Again it enters into what? Sleep mode. Once it wakes up, I becomes what? 1. Again it goes up, I becomes what? Sleep, and I becomes 2, like this. Right? So where it left the control, it starts executing from the same statement. That is a very important point. That is the reason why you can see 0, 1, 2s. Right? For threads. So here, it is left the control after printing 0. It is entered into the sleep mode. When it is again started, 1. Again it is started 2. Again it is started 3. And these two threads, thread 1 and thread 2 are nicely executing because each time only one statement is printed, sleep. Then the other thread, wake up, sleep. Now let us make our main thread also the same. Let us write the same code for main thread also. So in the for loop, I am going to do the same thing for main thread. So you can expect some kind of neat output. Each thread will be given. It's not compulsory each thread will be given only one opportunity, but almost you can expect the same kind of output. Right, now just this is my code here. So this is my try and close. This is my try close, and this is the cache block for the try block. Now let us run. So what happens each time? Each thread will enter into the sleep mode. Let's see the output of this. Each thread is executing. Before printing one statement, each thread is entering into some 100 milliseconds sleep mode. Now see this. Each thread will be given almost, they will be executing one by one. Almost you can give the same, you can guarantee the same output for almost times. Printing one statement entered into sleep mode. Once it is entered in, the time can be utilized by some other thread. It is also doing the same. It is also doing the same. You can expect almost the same output. Each thread will be executed one time. How many times you run? Almost. It's not always. Almost you can guarantee the same output. Each thread will be given one opportunity by making the threads sleep. So when to go for this sleep method? When to go for this sleep method? Where when you think a thread is right, when you think if a thread is moving very fast, it is executing very fastly, then you can slow up the thread. You can slow a thread bit by calling a sleep method. You can slow a thread bit by calling a sleep method here, by passing the time. How much time you want this thread to sleep? It is milliseconds, right? So here, like this, how much time you want a particular thread to sleep. Once it wakes up, it will not directly start executing it enters into ready state, from that again it should be picked by the thread scheduler for execution. No, no, no. See, main also I put what? In the main also I put the thread dot sleep. This is the main method. This is the main method. Here also I made it to sleep for 100 milliseconds. So what is main is also doing? For each iteration it is also going for 3 sleep method. It is also going for sleep mode. Then what happens here? When it is sleeping, the thread which is active, then that thread can utilize it and it can print it. Because I have written sleep mode, so each thread is going to sleep mode, right? So this run method will be called by 2 other threads and they will be entering into sleep mode. In the main also I did the same. I made my main method also for sleep. If I remove this, main always completes first. If I remove this, main will be completing first. Now each iteration main also goes into sleep. It should wake up. So what happens? 3 threads enters into what? With each iteration, all 3 threads enters for what? 100 milliseconds sleep mode. Then you can expect always the same output, right? If I make it to 50, what happens? If I make it to 50, that means what? So you can expect main will be executing 2 statements twice faster than what? The other threads, because they are sleeping for these sleeps for 100 milliseconds. This is 50 milliseconds, half of the time. So main will be performing 2 iterations. Those threads performs what? 1 iteration. That you can say that. And main will always complete first. This guarantee you can give. In this situation you can give guarantee that main will be always completing first. Main is already completed in the middle. See? Main is already completed in the middle. By these 2 are executed for 25 statements. Let's see this. Main is completed. Because each iteration main is executing twice. The thread which is having empty, the thread which is having active, it is going to utilize that time. It is going to utilize that time. So that means once a thread is in sleeping mode, the time will be utilized by some other threads. It will not, the other threads will not wait for that thread, just let their thread wake up, then I'm going to execute. No. Once a thread enters into this mode, the other thread can execute. Once it wakes up, then the thread scheduler decides here. So in this program, because main I have made main to what? Sleep at 50. So that you can execute what? Each iteration of those threads, main can complete 2. That's your dependent. So because I want my threads to move bit slower, then I can make the threads like a slower by calling the sleep method. Right now I am forcing my thread scheduler. Don't execute the threads how you want to execute. Now just do this. So that what happens? It is going to stop a thread for a particular period of time. Threads are entering into some other mode. But when they come from this mode back to ready state, again thread scheduler will pick one from that. You cannot guarantee. But in this output, in this program, obviously you always 100% you can guarantee that main will complete first. Which thread starts first, which thread no. Always main will complete first. And almost all 50th here. 24th and 25th, because main is started here first. There is a reason why you can see 2 iterations each time, right? So this is how we can force some. There are some other methods, still 1 or 2 methods you have, right? We will discuss them, right? So